sells
You
hamburgers.
can get the burgers there, but they're not licensed by any food company ever.
Yeah,
It's like some guy who
They're
sells
seasoned by
by
wood
the
chips.
Maybe there's a food
Alright.
truck outside.
Number 1, okay, arithmetic sequences are just sequences where they add the same values over and over.
5, 8, 11.
Okay, the next 3 terms, yeah, so they're just adding 3 on number 1, so what are the next 3?
11, 14, 17.
11, 14, 17.
Let's go.
How many do we have to do?
3.
3.
Okay.
Read the directions, my man.
I am very doubtful that you did. I think you just listened.
Nah, I read the
That
directions.
still counts.
That's okay.
Okay, what are they adding on number 3?
Negative 6.
Negative 6, so it would be
Negative 5,
negative 5.
negative 11, and negative 17.
Negative 17.
Where'd you go, Brady?
Brady concurs.
As long as Brady concurs.
Yep. Determine.
Determine whether each sequence is arithmetic.
Wait, what did we say after?
So arithmetic is adding, so as opposed to like multiplying and dividing. If it is, state the common difference. The common difference is the number you keep adding over and over.
5 is 4.
Okay, so on number 5, it's yes, it is an arithmetic sequence, and the difference is 4.
I'm on the ball today.
You're feeling it. You're in the zone.
It's, I got cards this morning, so I'm happy.
That's why.
Yeah.
Numbers.
What do you do if it's not? Just right
Just
now.
put no. Number 7, what are they adding? Or are they adding?
No.
There's subtracting
There's nothing.
a half.
They're adding
Oh.
negative a half. Subtracting is like adding a negative, right? So that is a yes.
Well, no, I thought the 2.5 was 2, comma 5.
Ooh, look at number 9. Yes. Kind of
What happens if it stays the same, like on 8? Like, is that just no?
on 8.
Or is it adding 0?
It's adding 0.
So are all of these yes?
No. Number 9 is, what are they adding? Well, it looks like 4, but is that really 4?
No, that ain't no 4.
Okay, Brady. Okay, Brady. What is it?
I don't know.
Okay.
Log 4.
Alrighty then.
Alrighty then.
Log, does anybody know what log of 1 is? Natural log of 1?
0.
Or common log, I mean?
10.
It is 0, because it's 10 to the what equals 1?
Yeah.
0. But
You guessed 0.
Nah.
So log 4
it
is
still counts.
actually.
It's like when you're shooting a 3 and you break it in, it still
Yeah.
counts.
It's
Oh my god.
counts for the same points, no matter.
Well, no,
When you finish up this much.
Okay,
that much.
but the next one, so the first one's worth 0, the next one is worth 10 to the what equals 5. It'd be like some kind of root. It doesn't work out very well. Anyway, you're not going up by a constant amount, you're going up by weird values.
Very
It
weird
is going up, but it's not, it's
So 9's a no.
9's a no.
So
When
if
in doubt,
you're
just
still
no.
adding in a sequence like +1, +2, +3, that's still 1, right? Because it goes through number 6. Does that count or does it have to be the same?
It has to be the same.
Okay.
Yeah, so on 6 it's adding 3, 4, 5, and that doesn't count. That's a good question.
So it's just no?
Yeah.
How the heck?
It is a sequence, it's just not an arithmetic sequence. It's got to be the same value. Okay. Where are we at? 11, right? The recursive. Okay, we got to learn what recursive is. So, what did number 1 say? Number 1 was 5, 8, 11, 14. So, one way we could think of this, a sub 1 is 5, a sub 2 is 8, a sub 3 is 11, a sub 4 is 14, and it keeps going, right? You can go forever. But this is just a way of like, a sub 1 means the first term, the second term, the third term, whoops,
Is it
third
recursive?
term, the fourth term. Anybody get it? So the way we write the recursive formula for that, how much is it going up by? This is number
4.
one.
Or
3.
Sorry.
So basically,
Wait, I'm sorry, what number is this?
He's teaching it.
Oh, okay.
each term is the previous term
Alright.
plus 3. You guys see how I did that?
Wait, okay, I think you get it.
Each term, this is just this can represent any term, is the previous term. So if this is 3, this would be 3 minus 1, the second term. The third term is the second term plus 3, right? Or the fourth term is the third term plus 3. So basically you always put a sub n equals a sub n minus 1 plus whatever you keep adding. That's not actually a problem, I just made that up. That would be number 1 as a recursive formula. Number 11, what are we adding on number 11?
We're adding -4.
Negative 4. So guess what I'm going to change?
Just
Instead of
Make it
plus 3, it's just a minus 4. Each term is the previous term minus 4 for number 11.
So, wait, do we have to add more to that, or is that?
That's it.
That's it?
It's called a recursive formula, yes.
What was it again?
Is the negative one like supposed to be smaller than the rest?
Oh, you're supposed to say what the first term is also. The first term, because yeah, you need to know where you're starting. The first term is, was it 7, wasn't it? Oh, number, yeah. So,
Can I do 13?
oh, yeah.
Okay.
Yeah, let me see.
Is it a in plus 11?
Yep. And go ahead and write comma a sub 1 equals negative 23.
Wait, what is that? The a equals 23.
A sub 1 equals 23. Negative 23. You need to say where they're starting at.
You did get a copy of it.
Got it anyway. Yeah.
This is for Rachel.
Okay, thanks.
Thanks, Melanie.
Don't you dare use your word. I swear.
Enjoy your coffee.
Money.
What?
Did you keep the money?
What money?
I didn't see that.
I didn't know. I was like, wait, did she just keep
You're not
it?
gonna. Well, that's a lot of money.
How much money did you give her for coffee?
That
Yeah.
lot.
You gave her a 20
You
for a
think-
cup of
you
coffee?
think-
All I had.
You
Jeez,
think
you're
coffee
like,
is
why?
20 bucks?
How dare you?
That's awful. Give her like a 5 or something. Give her like
$3.
Okay, so number 15, find the 20th term of each arithmetic sequence. Shoot, what the heck have you been doing this whole time? Alright, running out of time. So, let's see. It says the difference is 4, so that means it's going to go up by 4. The 21st term is negative 2. So, what is the 20th term? So,
Is there a way you can plug that into your calculator?
well, yeah, but you don't need to. It's easier. Okay, it's just saying the 21st term is negative 2. We're going up by 4.
So then it would
So
be
what must
2.
the 20th term have been?
Oh, we're going back
So basically what plus, so the 20th term is here. The 21st term is, I forgot, negative 2. So
So it's negative.
what plus 4 is negative 2?
Negative.
Yeah, the 20th term must have been negative 6, so we like negative 2 minus 4, basically. Go backwards. Negative 6 was the 20th term.
Wait, that's 13?
15.
Oh.
I didn't write 13 right above it. The answer is -6 and other stuff. Alright, 17. The 18th term is 169. The difference, the common difference is -5. So we're going down by 5. So what's the 20th term going to be?
159.
You're right. Go down 5. It's like going down 10, right? So the next 2 terms away will be 159. Basically, it's 169 minus 2 times -5. That's one way you can think about it. Or plus 2 times -5. Number 19, write a simplified explicit, okay, no explicit formulas. Blech.
Skip.
Nah. I wish there was only one kind of formula. Let's see, 19. So the other one we did was called recursive. That's one way to write it. This one's explicit is another way to write it. Let's see, I lost my place. 19. The first term is 7. We're going to be going down by 2. So it starts out the same. That's good news. What you do is, instead of a sub n minus 1, it's just going to be an n right here. You take the common difference times n, and yeah, a bit easier. Okay. We want, I'm going to write this. Let's put something there for now. We want a sub 1 to be, it tells us it's supposed to be 7, right? We want a sub 1 to be 7. So you get -2n plus what equals 7? Well, the 1 stands for what goes in for the n value. -2 times 1 plus what equals 7.
So, k equals 5.
If
Yeah.
you add, no, this is -2. So you add 2,
K equals 9.
it's 9. Okay, so what this does is basically, when on the first term, that n becomes a 1, and it's 9 minus 2, 7. That's the first term. On the second term, you get a sub 2, would be -2 times 2 plus 9. So you're going down 2 2's. Maybe it would make more sense if I wrote it with the...
Where'd you get the 9 from again? Sorry.
That was the name. You take it.
Alright.
Okay, this gives us 7, right?
Yeah.
The 1 is what's going to go in for the n. A sub 2 equals 9 minus 2 times 2, which is 5. A sub 3 would equal 9 minus 2 times 3, which is 3.
Okay.
Anyway, this is the answer right here. I'm just showing you why it works.
How did we do?
How did we get the 9 is because we needed the first term to equal. This is the common difference right here. But we need to make sure the first term equals 7 because that's what they told us it was. So what do I need to make this number? This is kind of like the starting number. The 9 minus 2 makes a 7.
Okay.
Yeah, so it kind of makes it tricky. There's probably a better way I could have said that. But anyway, 21. The starting number is, they don't say it explicitly, but it's -2, right? So what is, on 21, what is it increasing by? 3. So it's going to be 3n plus something. The something is kind of like the starting spot, but we need to make sure whatever I put in for k, I need to make sure that the first term is going to equal -2. So what would I put in for k to make this work?
K equals
This
negative
is
5.
3, yeah, so minus the 3 is negative 5. So, instead of plus k, I'm just going to put minus 5. You make sure the first term actually comes out as the first term. The second term, if I plug in 2, I should get the second term. If I plug in 3, I should get the third term. Every time n goes up, the value is going to go up by 3. N goes up 1, the value is going to go up by another 3. That's what happens. And the minus 5 just helps you with the starting spot. 23, find the 50th term of the arithmetic sequence. So the first term is 22. What is the pattern on 23?
Plus 13.
Say what?
Plus 13.
Plus 13. So does anybody have an idea how we could do it without like adding 13?
There's a
50.
button on the calculator.
50
Multiply
times.
it by 15 and then add 22.
Yeah, we're adding on, how many 13s are we adding on?
50?
46?
49.
Well,
Well,
50th. I thought they said
if you're starting from 22, how many 13s do we need to add on? If this is the first term, 49. So I would just do 49 times 13 plus 22.
600.
What was this number?
600.
23. Yeah, it should be 659.
Why was that 22?
Because this was the starting number. The first number is, whoops, I put the wrong one. It's 23. The starting number was 22. To get to the 50, between 1 and 50, there's 49 numbers, right? So I added on 49 13s.
Do we have to like?
And it is, yeah, it is 659, that's correct. Would be the 50th term. Oh, and I said we're stopping at 24, I guess. Okay, go ahead and work on that. If you guys have questions on this tomorrow, because we only got like 10 minutes.
Can you show me how to set up the formulas for like 18 through 22?
You mean 18 through 20?